Beneath the sun-drenched slopes of Sicily, a terrifying transformation is taking place that has left world-class geologists in a state of absolute disbelief. What began as a series of minor tremors and small cracks in the pavement has rapidly evolved into a geological catastrophe of unprecedented scale. Right now, the Earth isn't just moving, it is collapsing. We are witnessing a massive landslide event that has already swallowed 500 feet of territory into its designated red zone. But the latest data from the field suggests we are only at the beginning of this disaster. Specialized sensors and satellite imaging systems have just confirmed a devastating reality. The stability of the entire region has been compromised far beyond the initial estimates. Geologists on the ground are now sounding the loudest possible alarm, stating that another 1,000 feet of land must be evacuated immediately. This isn't a suggestion or a precautionary measure based on old models. This is an urgent, life-saving directive, driven by real-time readings that show the deep-seated layers of the Sicilian bedrock are sliding at an accelerating pace. If you thought the initial reports were concerning, what is happening at this very moment is on a completely different level of intensity. To truly understand why this situation has shifted from a local concern to a global scientific emergency, we have to look at the unique and treacherous composition of the Sicilian landscape. Sicily is a land defined by its beauty, but beneath that beauty lies one of the most complex tectonic environments on the planet. This region sits directly at the collision point of the African and Eurasian plates. This constant grinding and shifting create a landscape that is inherently unstable, but what is happening now is something much more specific and immediate. The recent landslide is being driven by a combination of extreme weather patterns and a phenomenon known as deep-seated gravitational slope deformation. This isn't like a surface mudslide, where a bit of dirt washes away after a rainstorm. This is a deep structural failure of the Earth itself. The ground is moving as a massive cohesive block, and as it slides, it pulls everything above it into a chaotic vortex of destruction. When the red zone was first established at 500 feet, officials believed they had outlined the maximum extent of the danger. They looked at the historical data, they looked at the surface cracks, and they thought they had a handle on the perimeter. But nature has a way of defying human predictions. As the leading edge of the landslide moves forward, it removes the support for the land behind it. This creates a domino effect that travels backward up the slope. Those additional 1,000 feet that geologists are now demanding be evacuated represent a massive expansion of the danger area. We are talking about homes, businesses, and critical infrastructure that were previously thought to be in the safe zone. People who went to bed thinking they were well outside the reach of the moving Earth are waking up to find that the ground beneath their feet is now part of the active slide zone. The stories coming out of the affected areas are haunting. Witnesses describe hearing a sound like a low, continuous groan coming from deep within the Earth. It's not a single loud crack, but a rhythmic grinding noise that signifies millions of tons of rock and soil are in motion. Paved roads are curling upward like sheets of paper. Sturdy stone walls, some of which have stood for centuries, are snapping in half. The visual evidence is staggering, but the data is what is truly terrifying the scientific community. GPS monitoring stations placed along the slope are recording movement rates that are doubling every 24 hours. In the world of geology, where things usually move at the speed of fingernails growing, this is the equivalent of a high-speed chase. Geologists are focusing their attention on what they call the slip plane. This is the specific boundary layer, where the moving mass of the landslide meets the stable bedrock underneath. In Sicily, the slip plane is often composed of clay-rich sediments that become incredibly slick when water is introduced. Recent heavy rainfall in the region has acted like a lubricant, turning those clay layers into a geological slide. Once the friction is lost, there is very little that can stop the momentum of a billion-ton mass. The teams on the ground are using ground-penetrating radar to map this slip plane, and the results are showing that the failure is much deeper than anyone anticipated. It's not just the surface soil that's moving. The very foundation of the hillsides is failing. This brings us to the urgent new evacuation orders. Why another 1,000 feet? Why such a massive jump in the exclusion zone? The answer lies in the concept of retrogressive failure. When a landslide starts at the bottom of a hill, it essentially pulls the rug out from under everything above it. As the bottom section moves away, the section behind it loses its structural support and begins to collapse as well. This process continues to move uphill until it reaches a point of natural stability. Based on the current speed and the depth of the slide, Specialists have calculated that the instability will migrate at least another 1,000 feet into the interior. If people are not moved out of this zone immediately, they could find themselves trapped as the ground literally dissolves beneath them. There is no way to brace a building against this kind of movement. No foundation is deep enough, and no retaining wall is strong enough to hold back the weight of entire mountainside. The logistical challenge of this evacuation is immense. We are talking about relocating entire communities on incredibly short notice. Emergency services in Sicily are working around the clock, but the terrain makes everything 10 times harder, because the roads are buckling and shifting. Bringing in heavy equipment to help with the evacuation, or to try and stabilize the area, is nearly impossible. In some areas, the ground is moving so fast that crews can't even finish marking the new boundaries before the land has already shifted past them. It is a race against time and gravity. And right now, gravity is winning by a significant margin. Scientists are also looking at how this event could trigger secondary disasters. When a landslide of this magnitude occurs, it doesn't just affect the land directly on the slope. It can block drainage systems, leading to flash flooding in nearby valleys. It can sever gas lines, power grids, and water mains, creating a cascading failure of infrastructure that impacts people miles away from the red zone. The geological surveys are showing that the shifting Earth is putting immense pressure on underground aquifers as well. If these water sources are breached or diverted, it could lead to further instability in areas that are currently considered stable. This is a regional crisis that is expanding its footprint every single hour. One of the most concerning aspects of this Sicilian landslide is how well it illustrates the changing dynamics of our planet's crust in the face of shifting climate patterns. While landslides are a natural part of geological evolution, the frequency and intensity we are seeing now are reaching record levels. The cycle of extreme drought, followed by intense heavy rainfall, is the perfect recipe for slope failure. The drought creates deep cracks in the soil, allowing the subsequent heavy rains to penetrate deep into the earth, right down to those vulnerable clay layers we mentioned earlier. This creates high pore water pressure, which essentially floats the mountainside off its base. Sicily is currently the ground zero for this phenomenon, and scientists from across the globe are watching the data closely to see what it means for other mountainous regions around the Mediterranean and beyond. What makes the situation in the red zone particularly heart-wrenching is the historical significance of the land. Sicily is a place where history is built into the very earth. Many of the areas currently being evacuated or swallowed by the slide have been inhabited for thousands of years. We are seeing ancient olive groves, some hundreds of years old, being tilted and torn apart. We are seeing family homes that have been passed down through generations developing cracks so wide you can see right through the walls. The loss of property is one thing, but the loss of heritage and a sense of place is a profound secondary effect of this geological event. The geologists know this, and it adds a layer of heavy responsibility to their work. They aren't just looking at charts and graphs. They are telling people they have to leave everything they know behind, because the Earth is no longer a reliable place to stand. As the search for solutions continues, some are asking if anything can be done to stop the movement. In smaller landslides, engineers can sometimes use soil nails, rock bolts, or heavy-duty drainage systems to stabilize a slope. But at this scale, such human interventions are like trying to stop an ocean liner with a piece of string. The sheer volume of material in motion in the Sicilian red zone is staggering. Some estimates suggest that over 50 million cubic meters of earth are currently active. When you have that much mass moving under the influence of gravity, the only real option is to get out of the way. The focus now is entirely on the 1,000-foot expansion of the evacuation zone to ensure that no one is caught in the next phase of the collapse. The technical equipment being used to monitor this situation is some of the most advanced in the world. In addition to the GPS sensors and ground radar, scientists are utilizing interferometric synthetic aperture radar, or INSAR. This is a satellite-based technology that can detect surface movements as small as a few millimeters from hundreds of miles up in space. By comparing radar images taken at different times, geologists can create high-resolution maps of the entire slide area. These maps are showing that the movement is not uniform. Some parts of the 1,000-foot expansion zone are moving as a single block, while others are fracturing into smaller, more chaotic segments. This fragmentation makes the landslide even more unpredictable, as smaller sections can suddenly break away and accelerate much faster than the main mass. As we look at the maps provided by the geological teams, The visual representation of the threat is sobering, but the projected 1,000-foot expansion looks like a giant shadow looming over the surrounding towns. Local authorities are using every available communication channel to reach residents. In some of the more remote areas, civil protection officers are going door to door, urging people to pack only the essentials and move to designated shelters. The atmosphere in these communities is a mix of frantic activity and a strange, somber silence. As people realize the gravity of the situation, every crack in a wall and every strange creak of a floorboard is now a source of intense anxiety. The geologists are also concerned about the potential for the landslide to reach the sea. In certain parts of Sicily, these massive slope failures occur near the coastline. If a significant volume of earth were to suddenly slide into the Mediterranean, it could generate localized displacement waves, which would pose a threat to coastal communities and shipping. While the current focus is on the terrestrial evacuation of the additional 1,000 feet, researchers are keeping a very close eye on the bathymetry, or the underwater topography, of the adjacent coastal waters. They want to know exactly what would happen if this giant mass of Earth doesn't stop at the shoreline. In the center of this crisis, the scientific community is learning at a rapid pace. This event is providing a wealth of data that will be used to update landslide risk models for years to come. But for the people of Sicily, the scientific value of the event is a small comfort compared to the immediate reality of losing their land. The realization that the red zone wasn't enough, that it had to be pushed back another 1,000 feet, is a wake-up call for anyone living in geologically active regions. It shows that our understanding of these massive Earth movements is still evolving, and that we must always respect the power of the natural world. The situation is fluid, quite literally. Observations from the most recent drone flyovers show that the topography is changing so fast that existing maps are becoming obsolete within hours. New ridges are forming where there were once valleys, and what used to be level ground is now a series of steep, unstable terraces. This rapid transformation makes it incredibly dangerous for anyone to enter the red zone, even to retrieve forgotten belongings. The risk of sudden, catastrophic failure is just too high. The geologists are adamant that the 1,000-foot buffer is the absolute minimum required to provide a safety margin, and there is a very real possibility that even this zone could be expanded further if the acceleration continues. What is particularly interesting about this specific landslide in Sicily is the role of the underlying geology. Sicily is famous for its volcanic activity, dominated by Mount Etna, but the geological complexity extends far beyond the volcano. The island is a mosaic of different rock types, from hard limestones to soft sands and unstable clays. The current landslide is occurring in a region where these different materials are layered on top of each other in a way that creates natural weaknesses. It's like a giant multi-layered cake, where the filling between the layers is starting to melt. As the heavier top layers press down on the weakened bottom layers, the entire structure begins to shift and deform. The international scientific community has turned its eyes towards Sicily, as this event offers a rare chance to see a massive deep-seated gravitational slope deformation in action. Research teams from across Europe and the United States are collaborating with Italian experts to analyze the data. They are looking for precursors, signs that could have predicted the sudden shift from a slow creep to a rapid slide. If they can identify these signals in the data, it might be possible to create better early warning systems for other parts of the world. But for now, the priority remains the safety of the local population and the successful execution of the expanded evacuation plan. The technical reports are highlighting a phenomenon called internal deformation. This is when the rock and soil layers inside the landslide mass are twisting and shearing against each other. This process generates heat and further breaks down the structural integrity of the material, making it even more prone to movement. It's a self-reinforcing cycle of instability. The more the Earth moves, the more it breaks, and the easier it becomes to move further. This is why the geologists are so concerned about the acceleration. Once a landslide enters this phase, it can be nearly impossible to predict exactly when or where it will stop. Looking at the broader picture, the Sicily landslide is a stark reminder of the dynamic nature of our planet. We often think of the ground as something solid and permanent, something we can build our lives upon with total confidence. But events like this remind us that we live on a collection of shifting plates and evolving landscapes. The Earth is constantly reshuffling itself, and while this happens on a geological timescale most of the time, there are moments when it happens on a human timescale. When it does, the results are both awe-inspiring and terrifying. The expansion of the red zone by another 1,000 feet is a direct consequence of this realization. Humans must adapt to the movements of the Earth, not the other way around. As the evacuation continues, the stories of resilience among the Sicilian people are beginning to emerge. Despite the fear and the loss, there is a strong sense of community. Neighbors are helping neighbors move their belongings, and local businesses are providing food and supplies to those who have been displaced. The local authorities are doing their best to provide clear information, but the sheer scale of the event makes communication difficult. The uncertainty of when, or even if, people will be able to return to their homes is a heavy burden to carry. For those now residing in the newly designated evacuation zone, the sense of urgency is palpable. They have seen what happened to the first 500 feet, and they know they cannot afford to wait. The role of water in this disaster cannot be overstated. Beyond the lubricated clay layers, there is also the issue of poor water pressure within the soil itself. When soil becomes saturated, the water between the particles actually pushes them apart, reducing the friction that holds the soil together. It's the same principle that allows a sandcastle to stand when it's damp, but causes it to collapse when it's either too dry or completely underwater. In the hills of Sicily, the heavy rains have pushed this poor water pressure to a breaking point. The geologists are watching the weather forecasts with as much concern as they watch the seismic sensors. Any additional rainfall could be the tipping point that turns this controlled evacuation into a chaotic race for survival. As we continue to monitor the situation, the data coming from the field remains grim. The displacement vectors, which show the direction and speed of movement, are pointing toward a continued expansion of the slide. There are no signs of stabilization yet. The geologists' warning about the extra 1,000 feet is based on the most rigorous scientific analysis available, and it serves as a final warning for those in the path of the disaster. This is not a time for hesitation. The Earth is moving, the red zone is growing, and the priority must be the preservation of life above all else. The technical challenges of monitoring such a large and active area are being met with incredible ingenuity. Engineers have deployed autonomous drones equipped with LiDAR technology, which uses laser pulses to create a three-dimensional map of the surface with millimeter precision. These drones can fly into areas that are too dangerous for human teams, providing a bird's-eye view of the developing fissures and the changing slope angles. This data is being fed into supercomputers that run simulations of the landslide's future path. These simulations are what led to the specific recommendation of a 1,000-foot evacuation. The computers are showing that if the current trends continue, the land inside that zone will experience significant deformation within the next 72 hours. The sheer scale of the displacement is hard to wrap your head around. Imagine a piece of land 3 football fields long and several football fields wide, and then imagine that entire area starting to move as one. That is what the 1,000-foot expansion represents. It's a massive amount of territory that is now considered too dangerous for human presence. The geologists are calling this a high-energy event because of the massive amount of potential energy being converted into kinetic energy as the hillside slides downward. This energy has to go somewhere, and right now it is being spent tearing the landscape apart. The impact on the local infrastructure is devastating. Power lines are being snapped like twigs as the poles. They are attached to move in different directions. Underground pipes are being twisted and sheared, leading to leaks that further saturate the soil and worsen the problem. Even the telecommunications network is being affected, as fiber optic cables buried in the ground are fractured by the Earth's movement. This makes the work of the emergency responders even more difficult, as they lose the very tools they need to coordinate the evacuation. It's a reminder of how interconnected our modern world is, and how vulnerable that interconnection can be to the raw power of geological forces. As geologists look deeper into the history of this region, they are finding evidence of similar landslides that occurred thousands of years ago. By studying the soil layers and the shape of the land, they can see that this is a cycle that has repeated itself over and over throughout history. The problem today is that we have built our modern world on top of this ancient, unstable cycle. What was once just a natural part of the landscape's evolution is now a human catastrophe. This realization is leading to a broader conversation about how we map and define safe areas for development in a world where the Earth beneath us is more dynamic than we ever imagined. The geologists' demand for an additional 1,000-foot evacuation is a testament to the severity of the situation. It is a bold, necessary move that prioritizes safety over all else. As the world watches Sicily, we are reminded of our place in the natural order. We are guests on a planet that is constantly in motion, and sometimes, that motion becomes a force that we cannot control. The best we can do is use our science, our technology, and our collective strength to protect each other and prepare for what comes next. The situation in Sicily is a powerful example of this reality, and the lessons learned here will echo far beyond the borders of this beautiful, embattled island. Every hour, new data points are being plotted, and new maps are being drawn. The scientific teams are staying on site, despite the risks, to ensure that the evacuation orders are based on the freshest possible information. They are the frontline observers of a planet in transition, witnesses to a geological event that will be studied for decades. Their courage and their commitment to the data are what stand between the people of Sicily and an even greater tragedy. As the red zone continues to expand and the Earth continues its inexorable slide, the focus remains clear. Move back, stay safe, and respect the incredible power of the world we call home. The sheer volume of the material involved is one of the most difficult things for the public to grasp. We aren't just talking about a few tons of rock. We are talking about the weight of entire mountain ranges shifting. This mass creates its own momentum, and once it's in motion, it possesses an almost unstoppable force. The geologists use the term inertia to describe how this mass wants to keep moving once it has started. It's not just the gravity pulling it down, it's the fact that 50 million cubic meters of Earth have picked up speed and won't be easily diverted or slowed. This is why the extra 1,000 feet are so critical. It's about creating enough distance between the people and this massive, moving wall of Earth. In these final moments of our analysis, it's important to recognize that while the focus is on Sicily, this is a story that resonates globally. From the Andes to the Himalayas, and from the Alps to the Rockies, similar geological pressures are at play. The scientific discoveries being made right now in the Sicilian red zone will help engineers and geologists around the world better understand the risks in their own regions. The technology being used, the models being developed, and the hard-won experience of the teams on the ground will all contribute to a safer future for people living on the front lines of geological change. The story of the Sicily landslide is still being written. With every inch of movement and every new evacuation order, a new chapter is added to this unfolding drama. It is a story of scientific discovery, of human resilience, and of the incredible, sometimes terrifying power of nature. We will continue to watch, to learn, and to share the updates as they come in. For now, the message from the geologists is clear. The danger is real. The Earth is moving, and the safest place to be is far, far away from the expanding red zone. The additional 1,000 feet are not just a line on a map. They are the difference between safety and a catastrophic encounter with the raw power of our shifting planet. Stay tuned as we keep a close eye on this developing situation, bringing you the latest data and the most urgent updates from the heart of Sicily's geological crisis. The Earth has spoken, and it is our job to listen and react before it's too late. The landscape is changing forever, and we are witnessing it in real time. This is the reality of our dynamic world, and the situation in Sicily is the most pressing example of why we must always stay informed and always respect the power of the ground beneath our feet.